Welcome to the last lecture of Chapter 2. Before we begin, however, let us just do a quick review of what we have covered so far. First, we looked at functional groups and the definition. Remember, the definition here for functional group is a specific region of the molecule where there are specific arrangements of atoms, typically heteroatoms. When we start doing reactions, we'll see another definition, and that is a region of the molecule where reactions occur. Next, we looked at saturated hydrocarbons. Saturated hydrocarbons here are organic compounds that contain only carbons and hydrogens, and the carbons are all sp3 hybridized. That is, they have 4 bonds to each carbon. Next, we looked at the classification of alkanes because there are so many alkanes, a lot, thousands of different alkanes. We can classify them into groups based on the type carbons they are. So we have primary, secondary, and tertiary carbons that are possible in the alkanes. And then we went into our nomenclature. We defined IUPAC as the systematic naming that we'll use in organic chemistry. We learned how to name saturated hydrocarbons, both straight chain and cyclic, and we also learned how to name alkenes, which have the functional group of a double bond, and we can name them if they are straight chain or if they are cyclic. Before we actually start the lecture though, let us just do a quick review on the nomenclature of an example here. This molecule is a saturated hydrocarbon. Notice all the carbons here are sp3 hybridized. There are 4 bonds to each carbon. So wherever you see an intersection, here for example 1, 2, the other 2 bonds are to hydrogens. So this is a saturated hydrocarbon. In naming it, identify the longest chain, and here it is, 7 carbons. We start numbering at the end closest to a branch. Here's a branch. So that's a heptane, and then we'll have to name the branches and indicate the position. One branch is a methyl on carbon number 2. The other branch is an ethyl, and that's on carbon number 5. So since E comes before M, we say it is a 5-ethyl because we have to indicate the position of the ethyl group. Next, it's a 2-methyl because we have to indicate the position of the methyl group. Notice we separate numbers from letters with a hyphen. So this is the name of this saturated alkane. Next, we looked at alkenes. So in naming an alkene, given the IUPAC naming system, we identify first the functional group here, which is a carbon-carbon double bond. We start numbering at the end closest to the double bond. So we start at this end and not over here, and we go and we determine that it has 6 carbons, which would have been hexane, but since it's a double bond, we change the A to E. We'll have to indicate the position of that double bond. It's between carbons 2 and 3, so we indicate it with a 2. Then we have 2 substituents here on the same carbon, 5. Since they are the same substituents, it's a dimethyl, and we use 5,5 because we have 2 methyl groups. And notice here a comma is used to separate numbers. Okay, so let's go into today's lecture. What we'll do here is we will cover the nomenclature of benzenes and substituted benzene compounds. And we'll also look at alkynes. That's a carbon-carbon triple bond. How do we name those compounds using the IUPAC naming system? Let's start with benzene. Benzene is a unique molecule. In fact, next semester there are a couple of chapters which are dedicated to the study of benzene. But here are three representations of the structure. You can see here it's a six-membered ring with three double bonds. Notice here the double bonds are between this carbon here, these two carbons, but over here it's not. And as we'll see later on, it becomes very tricky to draw the actual benzene structure because those 6 electrons are actually in rapid circulation above and below the ring. Another way of representing it is draw a 6-membered ring with a circle in the middle. So either of these representations here we can use to represent benzene. So look out for that as the functional group that has the benzene structure. Next, let's look at the naming of substituted benzene. Let's start with the monosubstitution. So here we have the benzene ring, as you can see here, and this group here is a methyl group. So basically we name it by just adding a methyl as a prefix to benzene. So that becomes methylbenzene. No surprise, this is nitrobenzene and this is chlorobenzene. Notice this compound here is also known as toluene, and the next slide explains why. There are some monosubstituted benzenes that have common names, and they are accepted names in the IUPAC system. So for example, benzene that has a methyl group is known as toluene. Benzene that has a carboxylic acid functionality, of course, as you know, is known as benzoic acid. If it has the aldehyde, it's benzaldehyde. If it has the OH, it's phenol, the NH2, it's aniline, and OCH3, it's anisole. So you may want to remember these names or have them handy so you can readily recognize that feature in a molecule if you're naming a molecule. So if there is a group that's bonded to the benzene ring, it becomes a substituted toluene if this were the molecule. So let's go over here, and that explains that a little better. So here's a nitro group, and here is the toluene group. So you will have to recognize the features that were on the previous slide. If you see one of those features, you will now name it as a toluene. In this case, it's a 2-toluene because the nitro group is on 1 and 2, the second carbon. This feature here, this molecule does not have a feature in the previous slide, so therefore we will just recognize the benzene ring here, so it's going to be a dibromobenzene. Notice again, it's a 1, 2, and 3 relationships, so it's a 1,3 dibromo. Here we have the same relationship, 1, 2, 3, but it's a bromo and a nitro, and of course B comes before N, so therefore it's a 1 bromo, 3 nitrobenzene. So be able to name substituted benzenes. Next, let's look at alkynes and naming alkynes. So if we have an alkyne to name, first we have to recognize or identify the carbon-carbon triple bond. Then we'll have to determine how many carbons are in a straight chain that contain the carbon-carbon triple bond. We start numbering at the end closest to the triple bond. So we start here. So 1, 2, 3, 4, 5, and 6. We know that would have been hexane if we are comparing it to just basically the number of carbons. But here's the trick. We change the A of the alkane to Y. So in other words, we're going to change this A here to Y. So we have here the hex sign. As you expect, you will have to indicate the position of that triple bond. So the Y is indicating the presence of a carbon-carbon triple bond. So, but you will have to indicate its position in the molecule. Because as you can tell, if it were over here, if it were here, it would have been a different molecule than the one shown here. So it is not surprising then that you should be able to utilize what we have discussed so far in terms of nomenclature to name branched alkynes. And this is where organic chemistry becomes easier the more time you put into it, because it's the application of basically the same set of guidelines and principles and concepts that we learn. So here is an alkyne. Here's the triple bond. We start numbering here. It has 6 carbons. We change the A to Y. We indicate its position by 2. There's a branch here on on the 5th carbon, and it's a methyl, so it's a 5-methyl. Again, numbers are separated from letters using a dash. And this one is another example here. Number of carbons, 1, 2, 3, 4, 5, 5. Notice there's a carbon here, and there's a carbon here. And the intersection there is a linear intersection. Why? Because we know the carbons there are sp hybridized. And we know the geometry of an sp hybridized carbon is linear with the bond angle 180 degrees. So look out for that. You will just see line and 3 lines followed by another line. Here it's an sp3 carbon, and of course the other bond is to a hydrogen. So if you're asked to name this molecule, 5 carbons would be pentane. We change the A to Y. We'll have to indicate the position of that Y, or the triple bond. It's in position 2 because we start at this end, because the triple bond is closest to that end. And of course on carbon number 4, it's a methyl group. So that's why we have 4-methyl 2-pentyne. Let's see if we can apply what we have learned here. And the question is, what is the structure of 4-methyl 2-pentyne? So once again, I would suggest starting right here. So start your analysis right here. So you may want to get a piece of paper at this point and write out 5 carbons. And on carbon number 2, we have a triple bond. Why? Because it's a Y in the name. And on carbon number 4, it is a methyl. So which is the correct structure here? Let's take a look. This is 1, 2, 3, 4, 5, but it does not have the 4-methyl. This is a double bond, and we know that this is a triple bond because it's an alkyne, so that wouldn't work. This one here is 1, 2, 3, 4, 5. Looks reasonable because that is a substituent in the 4 position. How about this one? 1, 2, 3, 4, 5, 6 carbons. So more than likely that would not work. So more than likely the choice would be C. Let's see what we got. And we do have C for the choice. So 1, 2, 3, 4, 5. And here is our methyl substituent. You should also be able to give the name of a molecule if you are given the structure. So here's an example. What is the IUPAC name of this molecule here? This molecule here. So it has 1, 2, 3, 4, 5, 6 carbons as the longest chain. Notice it's not 1, 2, 3, 4, 5, but you have to continue with the longest chain, 6 carbons. So it has to be a hexane as a starting point, and then we'll have to indicate the double bond by changing the A to a Y. So let's start our analysis here. The first thing that caught my attention looking at possible answers is pentyne. That's 5, so that's a problem. Pentyne, that's 5, that's a problem. So it has to be one of these two. So we're going to start our numbering here, 1, 2. So we know the position of the triple bond is in number 2. So this looks like it, because this is 4, and it's indicating the position of the double bond on the 4th carbon. Okay, so once again, you may want to really think through the naming of these molecules, because we will grade your answers based on how precise you write your answers. So let's see what's on the next slide. So it's no surprise then that the answer is right here, because we have here 2, and this 2 represents the ine, and it's 6 carbons, hexyne. And of course, the methyl group here is on the 4th carbon. So you should be able to go from name to structure, and if given the structure, give the name of these organic molecules, specifically here, the alkyne and the benzene molecules. Okay, so this is the end of chapter 2. So go ahead and read up on chapter 2. Make sure you understand all the concepts here in chapter 2. Equally important, or I would say even more important. Make sure you can apply these concepts to solving different problems. So go ahead and start reading up on chapter 3, which contains more functional group. We'll just probably do one lecture on that because it's fairly straightforward. So go ahead and start reading up on chapter 5. Your quiz, however, on Thursday will just cover chapter 2. So continue to study hard and continue to study organic chemistry consistently. Don't forget that, consistently. Make a schedule and study consistently. Okay? Bye.